Okay, now let's talk about the metric scale. I want to walk you through a visualization of the metric scale that I have. It may look a little different to you as you're sitting here staring at this number line. In middle school, you might have learned a method that involved a staircase. That method is perfectly fine. It works. I don't have a problem with it. But I visualized the metric scale in a linear function. That's more realistic of what it really is. Keep in mind, all metric units are linear functions. At any rate, let me walk you through this, and if you have any questions, feel free to come and ask. Keep in mind that the metric system and the metric scale is based on powers of 10. Any difference in unit, say from centi to milli, you remember that from middle school, just means change by a power of 10, or times 10, divided by 10, whatever. In the middle of the number line, we have base units. It's our home base. It's our starting point. Base units include meter, second, gram, liter. These are the actual measurement units. The rest of the metric scale is made up of a bunch of prefixes that just stand for numbers, but the base units are the real measurement units. Home base, remember everything's power of 10, home base is not 0, like on a number line. It is 10 to the 0th power, which is the number 1. In other words, 1 is home plate or home base on the metric scale. As we go to the left side of home base, our numbers get bigger. So we go from 1 to the next power of 10, which is 10. 10 to the first. That is one step between 0 and 1. All right, as we continue on, we get bigger, 10 to the second power. That's one more step, that's 100. One more step is 1,000, 10 to the third power. Now after that, we're going to take a giant step. We go from 10 to the third to 10 to the sixth. 1,000 to million. The reason for that is it was decided by the creators of the metric system that there was really no need to include prefixes for every number beyond 1,000. Big is big, so there's no need to just go through and just inundate ourselves with prefixes. Let's take another giant 3-step leap, and we go from 10 to the 6th to 10 to the 9th, million to billion, and do it one more time for trillion, 10 to the 12th. On the other side of home base, our numbers are going to get smaller. So we're going to begin that with 10 to the minus 1. That's one step to the right. That's 10th with a th at the end, 100th, and 1,000th, 10 to the minus 3. Then we're going to take a giant step again, and we're going to get millionth. So we go from minus 3 to minus 6. That's millionth. Another 3-step jump to the minus 9th, to the minus 9, that's billionth, trillionth. And on this side, I even included an additional giant leap to the minus 15th. Believe it or not, we're actually taking measurements that are on the scale of a quadrillionth. Now, I told you the metric system is basically a bunch of units or base units with prefixes that stand for these numbers. So here's the first one. Deca is the prefix that means 10. Notice it has a DA abbreviation. It is the only prefix with a 2-letter abbreviation that you'll ever use. And then we have hecto with a lowercase h. And the one you're most familiar with, probably kilo. Then, for those of you who are computer savvy, you have seen mega, as in megabytes and megawatts and all this good stuff. Giga, which is a billion, and tera, which is a trillion. Notice mega, giga, and tera have capital letters. I'll explain more about why there's capital letters here in a moment. But let's go to the other side of home base. We have deci with a lowercase d. Please don't get deci and deca confused. Recognize now that there is some possibility for confusion there. Come up with some way on your own, whatever you can come up with to keep those two straight. And then you're very familiar with centi, which means hundredth, not hundred. A century is 100 years, but a centimeter is a hundredth of a meter. Another source of confusion if you're not careful. And then we have milli, which is thousandth. And then we have one that students usually love every year, micro, as in micrometer, microscope, means very small. It is a millionth. Notice that we have a very unique symbol for micro. That is called mu. It is the Greek letter for M, or the Greek letter M in their alphabet. Why do we even have it? Well, if you'll notice, we had M for meter before. We've used M for milli. We even used a capital M for mega. So now that we have micro, we're basically out of M's and out of options, so we had to go to the Greek alphabet and use their M. So that's micro and mu. And then we have nano, which stands for a billionth, pico, which is a trillionth, and one of the new ones, femto, which is a lowercase f. It would help if you could memorize the metric scale, just as one of those life skills. You could always look it up, of course, but if you know it off the top of your head, you're going to be faster and more fluent with it. Now let's take some practices with the metric scale. Oops, let me talk about this before we go to some practice. The left side of the scale, we have numbers just getting bigger. And that's important. So it goes all the way out to, quadrillion and just toward infinity. Very big. But on the other side of the scale, and this is very important, make sure you pay attention to this. Most of you, if I asked you, where is this going, you're thinking negative infinity right now. Well, not quite. Actually, it only approaches zero. The metric scale, remember, reflects measurements, actual values. You can't have a negative value for a measurement. Therefore, the scale only approaches zero. It gets tiny and tiny and tiny fractions. All right, now we are ready to do some practice. So let's start out with an easy one. 675 millimeters, and we're going to convert that to hectometers. All right, so I'm just going to write this number down, 675. Now, as you're looking at your metric scale, what we want to do is count the number of steps that separate milli from the prefix hecto. So on your metric scale, put your finger on milli, and then find hecto. You'll see that it's going to be to the left, so we're going to go left, and count the steps with me. Milli to centi is one step. Centi to deci is a second step. Deci to the base is a third. To deca is 4. And then to hecto is 5. So we've moved 5 steps to the left. We will put eggs into these baskets here. Those zeros become our placeholders from our sig fig discussion. And now we have actually changed the unit, and we are in hectometers. It's not a good way to represent this number. It needs to be cleaned up and all that good stuff. We'll talk about scientific notation coming up, but the final answer would be 6.75 times 10. And count with me. 1, 2, 3. And I went to the right, so it's negative. Let's make sure we get a good negative sign there. Okay, well, we had some technical issues there. So I think we got disconnected at right the point I was about to make the final number. Just as a check, it was 6.75 times 10, and it was minus 3. I want to make sure you got that negative for the scientific notation part. Okay, so undaunted, we carry on. A second example here. 23.7 megaseconds to microseconds. Okay, so we need to count, find the direction we need to move, count the number of steps. Mega to micro is going to the right. So as I write it down, 23.7. Let's count the steps sort of together. So we go from mega to kilo, that's 3 steps, to hecto is 4, deca 5, base 6, deci 7, centi 8, milli 9, and then a big 3-step jump to micro, that's 12. So this is a 12-step move. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And there is the new decimal. Let's put eggs in the basket. 1, 2, 3. Kind of a tedious task. But if you're a chicken, you like it. All right, so there's our number. We're actually now in microseconds, and the conversion is over. It's done. You've done all your work. Now that's obviously a terrible number to try to write, so we're going to go 2.37 into scientific notation times 10. Excuse me. And let's count back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is where we started, but we need to put it here. So that's 13. So that's going to be 13. And we move to the left. This is a huge number, so we need a huge exponent. And there's the final answer. Except, don't be that person to forget the unit. Okay. Here's another one. Hit pause real quick. Try this. Look at your metric scale. Move the decimal along and see if you can do this one, and then I'll check your answer for you. All right, you should have had time to do that by now. So we have 9 nanograms. We want to convert it to deci. So identify first what direction we're going. Nanny to deci is going to the left. What an awesome arrow. Count the steps. Nanny to milli. I skipped micro. Nano to micro is 3 steps. Micro to milli is 6. To centi is 7. And then to deci is 8. So let's go and move this thing 8 places. 1, 2, 3, 4, 5, 6, 7, and 8. Let's double check. 1, 2, 3, 4, 5, 6, 7, and 8. And let's put all the eggs in the basket. Our place-holding zeros that aren't significant. And there we go. We are now into decigrams. Let's clean it up a bit. Scientific notation is 9 times 10. And converting just a single number is pretty easy. You just reverse what you did. There's no difference in the exponent and number of steps, so that's easy. 9 times 10 to the minus 8th decigrams. All right, so I hope you understand how to do that so far. Let me show you the shortcut method. This moving the decimal around is foolproof. It's very easy. It gets you the right answer all the time. But as you might have noticed, it's a bit tedious, especially if you understand the concept and you don't want to take so much time and space to do it. So here is how I actually do it now that I understand the metric scale. I'll follow 4 short rules. Rule 1, write the number you're converting. And then we're going to add times 10. That's the putting it in scientific notation part, the metric scale powers of 10 part. And then I'm going to write the exponent that the original prefix represents, such as nano becomes 10 to the minus 9. And then I'm going to subtract the unit I'm starting, I'm going to say the unit I'm starting from minus where I'm going and get the new power of 10. So that needs an example, I'm sure. So if I have, according to rule 1, if I take 14, that's my original number according to rule 1. It's rule 2 says add the times 10. All right, and then rule 3 says write the exponent that the original prefix represents. Well, my original prefix was giga, which is 9. Rule 4 says subtract from the original exponent the value of the new one. Well, pico is minus, I promise it is, minus 12. So now the new number is 14 times 10 to the 9 minus a negative 12, which is 21 picometers. So 14 gigameters to picometers is 14 times 10 to the 21st picometers. An enormous number. Put it in scientific notation. We need to go from here to here. So that's adding one more. So plus 1. So the final answer in perfect scientific notation is 1.4 times 10 to the 22nd picometers. All right. Here's another one for you to try. As I'm erasing, why don't you set that one up, hit pause when you're ready, and work that one out. And then I will check your answer very quickly. Wasn't that fun? Okay, so here's what I hope you have. 7.2 times 10. All right, now rule 3 says replace milli with minus 3. Rule 4 says subtract from that what you're going to, which is kilo, 3. So the final answer here, and there will be no scientific notation adjustments, 7.2 times 10 minus 3 is minus 6 kilograms. That one was pretty straightforward, but that's what I call the shortcut method. Feel free to use whichever method you want. You will not be required to do this or the other, but you just need to pick the one that suits your learning style the best. If you have any questions, ask me in class, and we'll do a few more pieces of practice to start the class off.